Hello everyone, my name is Miss Hanley and this is the first unit in Algebra 1. So today we're going to talk about an introduction to algebra. Hopefully most of this is review for you. And let's begin with the graduation standards that will be covered. The first graduation standard that is covered is reason and model quantitatively using units and number systems to solve problems. The second graduation standard that will be covered in this unit is interpret, represent, create, and solve algebraic expressions. And so as you may know from middle school, expressions mean that there are no equal signs, so the first part will just be dealing with simplifying, combining, and adding, subtracting, all of that, not solving equations yet. Alright, and the performance indicators that you will be graded on are use the properties of rational and irrational numbers, compute within the real number system, interpret the structure of expressions, and understand solving equations as a process of reasoning, and being able to explain that reasoning. As I said, we're going to work mostly with expressions, not equations yet, but we will get that. Also, we will be using reasoning quantitatively and using units to solve problems. That's very important. For today's lesson, your learning target is, I can perform operations such as addition, subtraction, multiplication, and division on rational numbers, including fractions. Keyword, fractions. I know that's everyone's best friend. Alright, so what we're going to start talking about is the real number system. And what is the real number system? Generally, when you talk about algebra, you deal with two number systems. We have the real number system, and then out here somewhere you have the complex number system, which deals with imaginary numbers. You will all get to that in Algebra 2. For Algebra 1, we're just going to focus on real numbers. Right? So real numbers are pretty much anything that you already know. From fractions to decimals to counting numbers to positives, negatives, zero, all of those are real numbers. So a few examples might be 1/2. You can have the fractions. 0.06. We can have decimals. We can have negative numbers. We can have positive numbers. We can have repeating decimals. Anything that you can think of that you've already learned about is probably considered a real number. And then inside of this big real number bubble, we also have irrational numbers. Irrational numbers are numbers that can't be put into fraction form. So numbers like pi, 3.14159, etc., that will go on infinitely, so it is not a rational number. It can't be made into a fraction. So it's irrational. Same with the square root of 2, or any decimals that just keep going and do not repeat. So 4.89671102 ... The ... afterwards means that it's going on forever and it doesn't repeat here. Alright? So next, we're going to work within the rational numbers. And there's a lot more categories within rational numbers. Both irrational and rational are considered real numbers. But if irrational numbers can't be written as fractions, then essentially the definition of a rational number is a number that can be a fraction or can be written as a fraction. So that includes basic fractions such as 1/3 or 17/12. That also includes whole numbers, numbers like 2. We could write that as 2/1. or -6. You can write as -6/1. Or even decimals like 0.25, which is the same as 1/4. Alright. Integers are numbers that can be found anywhere on your number line. So you can have negative numbers, positive numbers, and 0. But the only thing to remember with integers is there are no fractions. So -4, 0, 7, those are all integers. No fractions. Alright. Whole numbers are what you learned back in kindergarten. So starting with 0 and 1, 2, 3, 4, etc. all the way up as high as we can go. They're only positive, they include 0, and there are never any fractions or decimals. The natural numbers are almost the same as whole numbers, except for instead of starting at 0, they start at 1, and it is all of your positive numbers. These two distinctions get really important if you go into higher level math. There's a big difference between having a 0 in what you're working with and not having a 0, so that's why we distinguish those. So this is the entire real number system, and we want to make sure that we can add, subtract, multiply, and divide all of these things. Okay. So starting with integers, I know you had some practice with negative numbers in middle school, but we really want to make sure we have that down. When I think about adding two integers together or subtracting them, I just like to look at what sign they have and think about combining them. So rather than stressing out about whether you're adding, subtracting, whether it's a negative, positive, I just think about what are my two numbers doing. Alright, so let's start with the first one. You have -10, so let's say I'm back at -10 on a number line. Oh, actually, I should start. I'm going to say -10 is way up here, alright? So I have -10 and I'm adding to that -20. So when you add two positive numbers together, you're going to get a larger positive number. But if you're adding two negative numbers together, you should get a larger negative number. Starting at -10, we're adding -20 to that, and negative is to the left. So if I take away -20, that would put me down at -30. Alright. Next, we want to look at what happens if you have one positive number and one negative number. Well, -10 plus 20, that's going to be different than -10 plus -20. In this scenario, we're going to be starting at -10, and we're adding positive 20, so we're going in the positive direction. So if I add 10 to that, I'm at 0, and another 10, I am at positive 10. So I started at -10, I added 20, and I end up at positive 10. You can also think of this as 20 minus 10, which would give you 10. You can always move around your numbers as long as you take their sign with them. The next one we have to look at is -30 plus 6. Again, we could do 6 minus 30 if we wanted to move those around, and we end up with -24. We can also think, okay, so the absolute value of -30 is larger than the absolute value of 6. So when I combine these two together, I know that my answer will have the sign of the larger. So my answer has to be a negative. Next, since they're opposite signs, it's like subtraction. So 30 minus 6 is 24. Since my larger number was negative, I get -24. Again, with our number line, we could think about this. If we start at -30 and we add 6 to that, 1, 2, 3, 5, 6, we're going in the positive direction, and that would leave me at -29, 28, 27, 26, 25, 24, just like we got up there. Finally, if we take a positive number and subtract another positive number from that, this is basic subtraction. But you can also think about this as 28 plus a negative 9. If I start at positive 28 and then I take away 9, or I move backwards 9, I am at 17. So however you visualize adding and subtracting negatives, you really want to get comfortable with that. Even using your calculator, I'm hoping everyone can do this in your head, but make sure you know how to use your calculator as well. Talk about adding and subtracting rational numbers such